Hello and welcome to DEP2 feedback. So we've done this once already. Certainly my groups did a fantastic job of it, so we're trying it again for the second time. Okay, so just like you did in DEP1, the first thing that you need to do is to pause this video so that you can write in your successes and your targets. Some people in my class forgot to do this or hadn't watched it, I don't know what happened, but can you make sure you pause this, use your purple pen onto your front sheet of your DEP and write in your successes. Okay, so they're probably less than they were last time. That doesn't mean you're any less successful, it just means that the kind of successes were more concentrated. Then you can move on to targets. Okay, make sure you write the full target in. Okay, these targets are specifically written to help you do well in future DEPs. So last time they were a bit more specific to the particular DEP that we'd done. This time they're a bit more general. So there are ones to do with if you're using a photograph, what should you do, etc. Okay, so pause and write in your targets using your purple pen. Okay, in terms of your response, this is the same as last time. The first thing to do is to go through and correct all your spelling and punctuation errors using your purple pen. Okay? Secondly, whatever the teacher has written in the response box, okay, in the adjustment box, sorry, you need to complete in the box that says student response. For my classes, all right, there may be, in fact, there probably will be some A's, A for adjustment. Okay, to make that work properly, the best ones that I saw last time had numbered each of those A's and then written their response onto the front mark sheet. You might answer those on your work. Okay, people did a mixture of that last time and both worked really well, but you can only write on your work if it's quite a short answer that's required. And then make sure that when you're doing your response that you use the mark scheme. So the mark scheme is going to come up on this PowerPoint, but is also behind the front mark sheet that you've got with your DEP. Okay, so we'll get straight on to the first question, which is explain the concept of a sediment cell. Now, some of my students, when I started to look at your DEP preparation, hadn't included this as part of their DEP preparation, so probably will have struggled with this question. All right, so it's a kind of lesson in making sure that you revise everything that you need to be revising, and if you do that all the way through, you'll have good revision notes that you can use for the internal exam, at the end of year exam, and for the mock exams and the real exams next year. So, a sediment cell, okay, we usually describe it as a closed system. So a closed system means that there are no inputs or outputs. Okay, so some of you didn't quite get that right. So it's supposed to be, in theory, it's a closed system. Okay, so what some of you did to get another mark was that you said that in reality, often sediment does enter and leave, okay, the sediment cell. So that, although it's not on the mark scheme, I've awarded that another mark. Okay, so in addition to it being a closed system with no inputs or outputs, it's usually bounded by headlands, okay, prominent headlands, or it could be where there's a change in longshore drift direction. So most of you got that, okay? The second bullet point, not many of you got. So within a sediment, the processes that operate are the marine processes of erosion, transportation and deposition within a long-term cycle. So in the long term, sediment is moving around the sediment cell via transport such as longshore drift. It's being deposited and then eroded again, and it's part of a long-term cycle. Because this is in theory a closed system, the inputs of sediment, okay, would come from erosion of the seabed, okay, or the land through mass movement and erosion processes that cause the cliffs to collapse into the sea and therefore provide an input of sediment. Okay, there's little or no movement of sediment between the cells. That's similar to it being a closed system. Okay, but that would get you an extra mark. And you might have mentioned that human activity okay, like beach management such as beach nourishment, something like that, or groin placement, can interrupt natural systems, okay, creating an imbalance or moving away from dynamic equilibrium, okay, leaving some areas at risk of erosion. So there was quite a lot to do there to get you 4 marks, and certainly people in my class, lots of people sort of maybe have 3 points, 2 or 3 points, but we need to make sure we've got 4 points for the full 4 marks. The multi-choice questions, certainly most people seem to get those right, which meant that you understood those kind of basic definitions, so it was A and then B, okay. The next question related to this particular photograph, okay, and it was you had to talk about evidence that this area was eroding, okay, and it wasn't particularly well answered by people in my class. There were a few mistakes that people made. The first thing I would do if you've got a coastal question and you're looking at a photograph is to have a good look at it and try and work out what's going on. Now, when I look at this, I can see here that there's lots of sort of evidence of mass movement, okay, moving down the slope. I can also see that with the colour of this cliff and the fact that it's you know, not at a particularly steep angle, it's a sort of sloping cliffs, that this is soft rock or unconsolidated rock, boulder clay probably, okay, and some of you missed that, all right. So the sort of things that people were saying were things like this scree at the bottom of the slope. Scree is a pile of stones, okay? There is no pile of stones at the bottom of this slope, okay? There's some evidence here that I've just circled of slumping, but there isn't evidence of a pile of stones, all right? Because this isn't the sort of material that would produce a rock fall to give you scree, so that wasn't correct, okay? So some of you quite rightly said that there'd been some slumping down onto the beach and lots of kind of clay material that I've just circled for you that is on the beach, and that is evidence that's been eroded. What you need to be talking about here is the fact that the waves, the marine erosion, is undercutting the cliff, and because the cliff is being undercut, that helps to encourage the mass movement, the slumping, all right? The other things that we would write about here would be more human things that kind of tell us that this obviously is an area that's been eroded. So, for example, these buildings to the left of the photograph would not have been built so close to the sea. Okay, this one, you know, is a matter of metres away from the cliff edge. So that's evidence that, you know, that the land has been eroded. The fact that you've got a fence here that's kind of stopping people from going too close to the edge is evidence that there's retreat. You've got kind of things like these concrete bases of, you know, maybe other properties that have fallen into the sea, okay? So you would be looking for some of the kind of human type features that are evidence that this has been eroded. So looking at the map scheme, this isn't an A-level question, okay? So this is a legacy question, so you wouldn't get this type of question, but we wanted you to use the photograph. I wanted people to get better at using the photograph. So we've got things like the buildings appear to be precariously near to the edge, okay, which we've mentioned, especially in the distance, and the large building left to the centre, where the boundary fence goes to the cliff edge. Some appear to be abandoned, so some of the buildings, all right, I would say, you know, this building possibly looks like it could be abandoned, and obviously that's a sign that it's, you know, possibly going to go over the edge. The cliffs appear to be unstable. There's evidence of sliding or slumping or mass movement, okay, evidence of grass or vegetation or soil that may have been at the top part that's way down the cliff, okay, so you've got, it's a little bit difficult to see, but definitely where this crosses on the photograph, you know, that's evidence, isn't it, that there's stuff there that used to be much higher up the cliff, okay. There's material at the toe of the cliff, so at the foot of the cliff, that protrudes seaward. So you've got that clay that sticks out into the sea, indicative of recent possible movement. So that's a sign, an indication that there has been some possible movement. On the beach, there's possibly a line of boulders, indicative of the need to protect the coast. Okay, so you've got some sea defences, you've got groins in the background, and some sea defences over here, which are, sorry, wrong way, which are, you know, that's evidence that we need to be defending the coastline. And again, there's the business about there's earlier unsuccessful attempts to protect the coast. Okay, so quite a lot in there that some of you missed. So it's about sort of spending a bit more time thinking about what is this photograph showing, and then applying what you know to it. Okay. The next question that you had to answer was about this photograph. Okay, so it was using the figure and your own knowledge. Okay, so that's really important. So because it says and your own knowledge, we know then that this is an AO1 equals 2 marks and AO2 equals 4 marks. So this is an actual A-level question, which is in the style that you would get. Okay, so what you've got to do is assess the role of mass movement upon the development of this area of the Holderness coast. You were given some information underneath the photograph that you need to read. So we know that it's unconsolidated glacial deposits which lie on top of chalk. Okay, we can't see any chalk in this photograph, so what we're looking at here, the geology, is all glacial deposits, boulder clay. Okay, the landscape is dominated by deposits of till, boulder clays and glacial lake clays. We know it's soft, it's unconsolidated. They form a continuous lowland plain. Rainfall is below national average, but the area is prone to heavy storms. So we must make sure we read that information. What you need to be saying here is that the type of mass movement is rotational slumping. And the evidence for that is particularly the bits of vegetation like here, which have moved down, okay, and sort of back around, leaning back towards the cliff. This brown area that's where the slump has occurred, we need to be calling a scarp, so we should have been talking about that. And you should have been talking about how that mass movement process, how it affects the whole of the Holderness coastal landscape. Okay, so you wanted to be talking again about the cliff foot processes, the erosion processes that were happening at the cliff foot, okay, such as abrasion, that were undercutting the cliff foot and encouraging that slumping to take place, okay? And then you wanted to be talking about how that affects the Holderness coast. So things like, it's obviously going to be an input of sediment into the sea. So as the cliff slumps down onto the beach, that provides sediment for erosion. So you could have been talking about a positive feedback mechanism, because within the boulder clay you've got pebbles that are that are embedded into the clay, that when the clay becomes part of the sea and is carried in suspension by the sea, those pebbles can then be used by the sea for further abrasion of the cliffs. Okay, so you could be talking about a positive feedback mechanism. You could also be talking about the fact that the slump, once it's down onto the beach, protects the cliffs behind it during the period that the sea is removing that slumped down material. Okay, so that would be a negative feedback mechanism. The input of sediment obviously leads to longshore drift, okay, and further deposition further down the coast. So because you know Holderness coast, you might have talked about a spit forming at Spurn Head, okay, but if it was an unfamiliar area of coast, it would still be a sensible suggestion that there's transportation of the sediment that's been eroded, mass movement, and then eroded away by the sea and transported and then deposited somewhere else. Okay, so we needed to be thinking about how this rotational slump affected the whole of the coastline. If we look back at the mark scheme, without kind of going through absolutely everything, you want to be looking at, when you're trying to prove your answer, this bit on notes for answers. So in terms of AO1, knowledge and understanding, remember AO1, okay, you wanted to be talking about the geomorphological process of mass movement, okay, and talking about how slumping occurs. Okay, so you should have been talking about rotational slumping. And then talking about the landform, that had been formed in terms of that rotational slump with the backwards tilting vegetation and so on. And then in terms of your kind of AO2, your application, okay, recognising that it was rotational slumping, okay, was good. Looking at some of the factors which may have led to mass movement, okay, so some of those factors obviously would be geology, okay, so you'd want to be talking about the geology being soft and consolidated rock, which leads to slumping. You could also talk about the rainwater, although it did say that the rainfall is low here, lower than average, but when it does rain, when there's a storm, there's lubrication of the boulder clay that encourages it to slump down. You could also talk about those storms that were mentioned underneath the photograph, and how when there's a storm or a storm surge, that would cause more erosion at the foot of the cliff and more slumping, etc. Something that not many people mentioned was this idea of a change in the shape of the cliff. So basically, because of the slumping, you've gone sort of like this, okay, and you've reduced, so as the rotational slump has gone down, you've reduced the angle of the cliff here. Okay, so the cliff is at a lower angle because of that slump. All right. Again, here it's got the stuff about soil being saturated, etc. Doesn't mention the storm, but that would, you know, the prevailing weather would be included there. Okay, so it's level marked is the 6-mark question. So if you've got clear knowledge and understanding, okay, it could be level 2. If you've applied your knowledge and understanding with clear analysis and evaluation, okay, that would be level 2, but it's basic and limited for level 1, okay? But obviously you haven't been given an actual mark for this. Okay, so we've had a look at that one. So the last question was, relating to this source, okay? So you were asked to look at these 2 sources, which you have looked at, maybe not, they don't look exactly the same as the ones that you looked at in class, but you know, it's very similar. And you're asked to, just remember the actual question, I don't know if it's on the mark scheme, no it isn't, so let's just remind ourselves of what the actual question was, so that you know what you're doing. So this is another one where it was using the source and your own knowledge. Okay, so be with you in 1 minute when I find the actual question. So the actual question is coming up now. So I don't know whether I can probably put this on the screen for you, although you've probably got yours in front of you. So it's using figure 6 and 7 and your own knowledge, account for the development of this area of the Dorset coastal landform. So some of you were slightly thrown by, and I remember people asking me in class, account for, okay, so account for basically means explain the development of this area of the coastal landform, the coastal landscape in Dorset. Okay, so you had to explain how we get these particular features. So you needed to be talking about geology, very much so. So if we're looking at this section of the coast here, which obviously relates to this bit of the, in fact we go right up to the, you can see the Mupe rocks, the stacks that are there. So that part of the coast, most of my class definitely got this right, that it's a concordant coast, okay, where the layers of hard and soft rock are parallel to the sea. Okay, so what you needed to be talking about was the hard rock here is the Purbeck limestone, is resistant to erosion, but at some point of weakness, which most of you identified as being a joint or a bedding plane, that the sea has attacked that point of weakness and got through to the much weaker rocks behind, which are the Wealden, marls and sandstones that have eroded much more quickly. Now you needed to be talking about specific erosion processes. So in this case, because it was in a joint, in a hard rock, you wanted to be talking about hydraulic action, okay, and going alongside hydraulic action, you wanted to be talking about cavitation. So if you're not very confident on those processes, that's something that you need to be working on. So once it got through that hard rock, then the erosion, all the erosion processes can start to happen. And so on the Wealden beds you get this, and some people would really good to see people describing it as a unique landform. Lulworth Cove is a highly unique landform. I don't know of another one in this country. Okay, so you wanted to be talking about a unique landform that's formed, and then at the back, and it's a bit easier to see on the on this one than on your photocopy actually, that the Portland limestone at the back of the cove has reduced the speed of erosion because that's a much harder rock. So here at the back of the curve, or here on the photograph, all right, the harder rock is now limiting the amount of erosion that would take place. It will slow down considerably. Okay. The other things that you could have mentioned were the Mupe rocks, which are stacks. Okay, so you can see those individual little blocks of rock. Okay, so of course the concordant coast is here, but this one here forms a discordant coast. Okay, and again, Mupe Bay has been eroded on the marls and sandstones, the Wealden marls, on the soft rock. Okay, whereas the harder rock, the Purbeck limestone, is sticking out as a headland here on the photograph. Okay, so you've got a definite headland sticking out there with some typical stack formation. It would have given you lots to write about if you could talk about the formation of stacks, which would have been fantastic. Okay, so we have a really quick look at the mark scheme. So again, you can see that it's level 2 to 4 to 6 marks, level 1 1 to 3 marks. So this one's the same as the previous question in terms of how the marks are awarded: 2 for A1, 4 for A2. And the things that we needed to be talking about were, if we look at the notes for answers again, okay, the distinctly coastal processes. They just list them all, but you needed to really pick the ones that were so important for this particular landscape. And you want to be talking about hydraulic action, cavitation, and you need to actually explain what those processes are, how they actually happen. Okay. Then it goes on to look at the origin and development of landforms and landscapes of coastal erosion, cliffs and wave-cut platforms, perhaps less important, but you've definitely got here the waves, arches and stacks, so you could have talked about those. That were there. Coves isn't mentioned there, but coves was the main, or the cove was the main landform that you would talk about. You might start to talk about beaches, because there is a beach here in Mupe Bay, so you could talk about deposition, okay, in Mupe Bay. Go backwards. Swine, it's gone forwards. Oh no, disaster. Okay, don't worry, we'll be back in a minute. Okay, don't know why we're there. Okay, so yeah, you could talk about the formation of the beach. Obviously you all talked about erosion, that was fine. Then it talks about the specific types of erosion that might be particularly relevant. The stacks, it's hard to see them because obviously you're looking at an overhead view, but what they wanted you to talk about was weathering. So remembering that there are subaerial processes that are acting on the stacks, as well as the marine processes of erosion that are happening as well. Definitely there should be some acknowledgement of local geology, so you should have been talking about concordant geology running parallel, okay, more resistant erosion like we've just talked about, so this is all the bit that we've just talked about. You could here have talked about at the headland, you could have talked about wave refraction as well. You might have talked about longshore drift, so longshore drift taking material away, and deposited, but not a real lot of beach formations, although it does mention, as I have, that Mute Bay, there is a beach. Okay, so all is left for you to do now is to look at whatever your teacher has asked you to do and use the mark scheme to help you respond in whatever way they've asked you to. And good luck with that, and we'll see you next time. It's DEP feedback.